Hey guys, this is Dr. Callahan with Week 5 Tuesday for Algebra 2 Semester 2. This is your warm-up question for today. So I'll go ahead and pause the video and answer the following 3 questions. Okay, so keep in mind that week 5, we're in week 5. This is week 5 Tuesday. You guys have your Math Excel assigned over there. The Math Excel is going to be focusing on graphing rational functions. I'm going to give you guys a little bit of time in class on Thursday to work on that. Tomorrow is Wednesday. On Wednesdays, you guys have your assessments on Math Excel. So I don't give you guys tests in class. Your assessments and quizzes will always be on Math Excel. I'll give you guys time in class on that to do that on Wednesdays. But also, you have your grades will be updated. So everything that you've done last week for Math Excel, assessment, and homework, I will update those 2 grades in addition to everything that you guys turned in class. So every Wednesday, you guys will have your grade updated. I post it on IC, of course, but it'll also be on Teams, just in case you guys need it. But this week's week 5's assignment for Math Excel homework and then also Math Excel quiz will be due on Sunday by 11 p.m. And of course, your grades will be updated every Wednesday, just so you guys know. So then moving on, how do you go about raising your grade? There are several suggestions. One is your Math Excel, your quiz, and also your homework. Make sure you guys have that done. If you haven't done the ones for week 4, 3, 2, or 1, you still have access on it. It's due every Sunday by 11 p.m., but by Monday, open all of them. So you have until June to do it, but the sooner the better because there is a late penalty of 10 to 40%. So if it's going to be if you don't complete until June, you might get the 40% deduction, okay, which is better than getting a 0. But then if you do it like a week later and it's only a week late, then you'll only get a 10% deduction. And that's just to be equitable and fair for people that actually do turn things in on time. So yeah, also I have after school tutoring. So if you have any questions, if you're concerned about raising your grade, please just come see me in person after school here in this classroom. All right, if you've been absent excessively for the last few days or few weeks, remember this is your QR code. You just need to go on to this one link and you will have access to the 18 videos that you guys have literally been going through in class that I video record. So you have access to every single lesson that you have missed, okay? So rather than go, do I have any extra credit? I don't have any extra credit assignments, I don't. So to pass this class, you just have to do the work that you missed, you know, and once you do complete it, you just bring it up to me. I'll just change your grade. It's really as simple as that. But there are 18 videos there. They range about 20 to 30 minutes because literally this class is about 50 minutes and I give you guys a little bit of time in class to do certain work. And so anything that you've missed, like from yesterday, week 5, Monday, it's right here. I just upload it immediately after class so you guys have accessibility to it, okay? All right, let's go ahead and get started with today. So today is Tuesday, February 1st. I can't believe January is already done. And before you guys know it, the school year is going to be over. You know, spring break is 5 weeks away and it's all going to go down here from there. It goes pretty quickly after that. So today we're going to talk about graphing rational functions and transformation. So that is going to be the topic of today. We're done reviewing and me prepping you guys for this unit. We're just going to jump right into it. We have about 4 days to spend on this because it's not exactly an easy subject, but we'll have 4 days to kind of like get you guys ready for everything else. And then next week, we'll start with multiplying, dividing, which is not as difficult. But then when we start with adding and subtracting, those are going to be a little bit challenging. And we're going to end up with solving rational expressions in the unit at the end of February. So if you want to take a glance at what we're doing, that's how everything is organized. So today, transformation of rational functions, day 1. I have a quizzes that hopefully you guys will get to because I know the last few days I try to have you guys do some technology work, but I never get to it because there's just so much stuff to do. So the materials you need today, and there's several, 3 sticky notes. You need a TI-84 calculator, a highlighter, and then also an iPad if you don't have it. So come on up, you guys. Your iPads are right here. Your TI-84 down there. Here is your highlighters, which I'm dropping everywhere, but that's okay. So just come up and grab a bag of highlighters. And then you also need to have 3 sticky notes. So grab any 3 sticky notes of your choice. All right, so this was from yesterday, you guys. It's from that single paper that I gave you guys. I just want to make sure, do you guys have any additional questions from here before we go any further? You guys have questions number 1 to 16. The answers are right here on the very bottom. Is there one question in particular that you would like me to kind of like go over with you guys beforehand? Or if you have any questions about this? Because you'll need to know how to factor this as we progress into rationals. Any questions, a number that you would like me to go over at all? Maybe I'll just pick one just to ease the transition a little bit because you guys are all knocking down the doors to answer them. Let's do number 6. Okay, so for number 6, it's interesting because when my freshman level class, we're actually doing this as well. And they're like, we don't need this. We're not going to go over this again. I'm like, no, you do, because when you become juniors, you're going to go over this material again. And then as seniors, depending on which level of math class you go into, you'll need this again. All right, so our goal is to put this into 2 different parentheses. You're going to take the 2, multiply the negative 30, and then you're going to create a table. So 2 times negative 30 is going to give you a negative 60. So you put the negative 60 on the left side. Your middle number is a 7. And so here you do have negative numbers. So all the factors that you have to have a negative. So what negative number times each other give you a negative 60? And unfortunately, there's a lot. It's negative 1 and 60, positive 1, negative 60. I could do a negative 2 and 30, positive 2 and negative 30, negative 3 and 20, positive 3 and negative 20. We could do a negative 6 and 10, 6 and negative 10. We could do a negative 5 and 12 and 5 and negative 12. So there's obviously only one that will add up to a positive 7. So which one is that going to be? And I think the only one that works in this case is this one right here that I'm highlighting, because negative 5 plus 12 gives me a 7, right? So that is my answer, my temporary answer. So you're going to put R and R minus 5 plus 12. But that's not your answer, because obviously if you FOIL it, you're like, that's not going to give me a 2R squared. And you're right, it's not. Remember how you initially times by 2 on the top? Well, you got to undo that. So what's opposite of a times? Divided by 2. Okay, so a lot of people forget the step. So 12 divided by 2 is just going to give me a 6. But then this 2 doesn't go into 5. So what do? And this looks really weird, but you just put in front of the R. So 2R minus 5. And this right here is your answer. And if you're to FOIL it, it will give you the same answer as the original question right there. And that's what you should have. I hope you guys kind of remember this from Algebra 1. I know it was like 2 years ago when you guys were in the middle of a pandemic and maybe you don't remember it, but Algebra 2 is a continuation of Algebra 1. So that's why I'm kind of reviewing this with you guys, so that when we get to rationals, adding, subtracting, multiplying, dividing, you're not like completely lost. Okay, so today let's go ahead and jump into our stuff. You do need to have 3 sticky notes, highlighters, and then a TI-84 graphing calculator. All right, so let's go ahead and take a look at your page 8 of your guided notes. Your guided note is your white packet. I'm gonna give you guys a second to get there, and then we'll fill out this part. I know we haven't really used this notes hardly at all this year, or this for this unit, mainly because I've been prepping you guys to get ready for this unit. But I feel like there's at a point where I'm like, okay, let's just jump in the deep end and get this started. All right, so let's take a look at this. It says an asymptote is a line that a graph comes close to, but does not touch. I know that's a lot. I'm sorry, but essentially that's what it means. So with your highlighter, your asymptote in this case will be this green line, and it will be this blue line. But do you see like your graph, which is in orange? It comes close to it, but it doesn't go past it, okay? And it doesn't touch it. It gets very close to it. And so once you go on and highlight that, you want to label it. This green line is going to be your horizontal asymptote. And then this blue line is your vertical asymptote. And I just put ASY for asymptote because it's too long to spell. So the horizontal asymptote guides the horizontal graph on the x-axis of a rational function. And the in behavior. In behavior means you look at the end of the little arrows, okay? So as x approaches, I'm going to start off with negative infinity, okay? So as x approaches negative infinity, so this is where it's going, negative infinity, right here on the x-axis, where do you kind of see the y value going? I don't know. I mean, you see this green line. Where is that green line at? It looks like this end is kind of like getting closer to the green line, but it's not touching the green line. And that green line is y is equal to 2. As x approaches positive infinity, so this is going to be the positive infinity side, where is your y going? Your y is still going to 2. Now, on the other hand, on the side, I just want you to write this one. You're going to put as y approaches negative infinity and as y is approaching the positive infinity. I know that's not part of it, but I'm just going to give it to you guys anyways. So as y approaches negative infinity, so it's talking about this arrow down here, okay? So it's going down to the negative infinity. Where is your graph going? Your graph is kind of getting closer to the blue line. And what is that blue line? X is equal to 3. And similarly, as y is approaching positive infinity, which is going up this way, that end behavior is approaching to the blue line, which is also x equals 3. Asymptotes. Vertical asymptote means it's this line going up and down, and that is x is equal to 3. Horizontal asymptote is left to right, and that is y equals 2. All right, so there is an equation, obviously, that comes along with this. So let's take a look at the equation, okay? So here's the equation, graphing the form of HK form. So HK oftentimes is a vertex, and this is the equation that you want to fill out with, okay? So G of X is equal to, you want to put A on top right there, minus H plus K. That's your equation. And obviously they mean things, so I'm going to tell you what they mean. Okay, so with your highlighter, you can go ahead and highlight the K. The K right here is going to tell you the horizontal asymptote, okay? And the horizontal asymptote is going to be x equals something. No, just kidding. Y equals something. Yeah, sorry. Now, the other one that you need to highlight is this negative h right here, okay? This negative h is going to tell you the vertical asymptote. I'm going to put VA just for vertical asymptote, just to save some space. And then this one is going to be x equals some number. And to solve for the vertical asymptote, and you want to make sure you have this down, you're going to put set denominator equal to 0, solve x. And that's how you find the vertical asymptote. The horizontal asymptote, there are some rules affiliated with that. And I'm not ready to tell you guys the rules yet, but I will eventually. Okay, so now with that said, let's grab our graphing calculator because I feel like you guys are ready to graph some of the stuff and find it. Okay, so your next question is, it says exit ticket, but you can just ignore it. That's totally fine. It says find the horizontal asymptote, okay, of the graph of the rational function. This is what you guys have right here. Now, going back to this equation that we have, just based on looking at this equation where the horizontal asymptote is, just think about it. Like, what do you think that's going to be? I'm thinking maybe 0 because there's nothing attached to it. You know what I mean? Like it's supposed to have a plus K and that's a horizontal asymptote. And here there's like nothing here, you know? So I'm thinking 0. But just to make sure, grab your TI-84 calculator. Let's just give that a try. And let me share that over here. All right, so here's my graphing calculator. I'm gonna go to y equals, I'll clear that. And it's gonna be 3, I'm gonna put in parentheses, divided by, because whenever there's like, you know, fractions, you got to put things in parentheses so that way the calculator knows how to use order of operations. I know it's a calculator, it's very smart, but it doesn't have artificial intelligence and it's not able to do that. So then type in 5x and then close your parenthesis. And graph. Okay, so we're looking for the horizontal asymptote. Okay, so then looking at your graph, which I can't make it any bigger than this. So here's your graph. Horizontal means it's gonna be this line going across right there. Do you guys see that line right there? And what does that line look like? Because if this is my horizontal asymptote, is my blue graph crossing that? No. And the horizontal asymptote in this case is what? It is going to be a 0, y equals 0. And that makes sense because it's literally the blue graph is not crossing that. So when I look at this initially, I was like, okay, it's probably 0. My horizontal asymptote is y equals 0. And then after I graphed it, I did validate that because here it is. There is your horizontal asymptote. And guess what? Your blue line does not cross it. So it's y equals 0. So 2 ways. You can either use the formula or you can go ahead and graph with a TI-84 calculator. Okay. Now let's go on to the next one. I know this is warm up, but you can ignore it. Now we're going to talk about how to find the vertical asymptote. Okay. With your vertical asymptote, you take the denominator and you set it equal to 0. So VA equals, take the x squared plus 3x plus 2, set it equal to 0. And you're supposed to solve for x, right? And this is why we practiced this yesterday, so you guys can go ahead and practice with it. Create your chart. Your last number is 2. Your middle number is 3. they're all positive, so you only want the positive number. So what times what gives me a 2? 1 and 2, right? There's no negative number, so you don't do a -1, -2, it's just 1 and 2. Does 1 plus 2 equals 3? Yep, so it's gonna be x plus 1, x plus 2 equals a 0. And then you're gonna solve for this. If I were to do x plus 1 equal to 0, x plus 2 equal to 0, let's solve for it. Opposite of a plus 1 is a -1. Opposite of a plus 2 is a -2. And when I solve for this, x equals -1. There's your first one. X equals -2. There is your second one. So those are my vertical asymptotes. So what that means is here's my graph. And I'm going to go ahead and have -1 right here and -2 right there. So I'm going to have these two lines going up and down. And my graph is going to be somewhere around those two lines. Like it's going to come close to those two lines, but it's never going to touch those two lines. Okay, so let's graph this and see what it looks like. So with your TI-84 calculators, so here is mine. I'm going to go back to y equals. I'm going to clear that up. And when you're graphing this, you guys, you really need to be very careful with parentheses. So with my numerator, there's my parenthesis. I'm going to do x squared plus 2x. Oops, let's see. How do I delete that one? Delete. Okay, 2x. There we go. Plus 1. Close your parenthesis. And then hit the division button and then open another parenthesis for your denominator. And make sure you're practicing with this as I'm doing it, because you're going to have to do this on your own on your common district final. And you got to know where the buttons are. And then close that parenthesis. So this is how you'll type it into your calculator. And then let's go ahead and graph it. So I'm going to hit graph. And sure enough, take a look at that. This is going to be my graph, and I'm just going to plaster it right over here. Actually, I think I'm going to do that here. Over here. Sorry, I have to move around a little bit so that way I can see a little bit better. So at -1 and -2, here's your -2. And guess what? Your graph is not touching that at all. Okay, so there is your graph. Go back to this. There you go. All right, let's go on to the next one, you guys. So here we go. Here's your notes for number 2. We're going to graph this equation right over here. What is your vertical asymptote? What is your horizontal asymptote? Remember your notes that we just went ahead and typed up, okay? There was that little formula that I had you guys do, which looks like this. I'm going to carry that over here so we can use that as like a guideline, okay? So here's your little note, okay? Vertical asymptote. Vertical asymptote is always going to be on the bottom. So it's that a +2, but you see how it's a minus h, so it has to be an opposite. Okay, so what's opposite of a +2? It's going to give you x equals -2. Horizontal asymptote. Your horizontal asymptote is going to be that number that is tagging along at the very end right here. Now this one, you don't do the opposite. It is just what it is. So y equals -3. If you have your cell phone out, please put your cell phone away so you're paying attention to what we're doing. And then your y-intercept, okay? So what is a y-intercept? A y-intercept, if this is your graph, it is your line hitting the y-axis, okay? So this is saying, one second. Give me a second. Okay, so it's when the graph crosses the y-axis. And so here's my y-axis right here. So when x equals 0, what is y equal to? Okay, so to find the y-intercept, set x equals 0. So let's go ahead and do that. So I have y, g of x right here, you guys, you know that's y. Y is equal to -2 over 0 plus 2 minus 3. You just go ahead and calculate it. -2 divided by 2 is going to be a -1 minus 3. Guess what? Y equals -4. That is your y-intercept, okay? To find the domain and range, you will literally have to graph this. So let's go ahead and graph this on my graphing calculator. I know for a fact that my vertical asymptote is at -2 right there. My horizontal asymptote is at -3 right there. So I'm going to go ahead and just draw this. So my vertical asymptote is going to be highlighted with this line right here in green. And then my horizontal asymptote is going to be highlighted with this line in blue. So my graph is going to go around those two lines. It's not going to touch it, okay? But my y-intercept is at y equals -4. So what that means is my graph is going to cross this. So I have a feeling my graph is going to look something like this. And it might go up a little bit, but it will never pass the blue and green line. But I don't know exactly for sure what it looks like because I haven't graphed it yet. So I'm going to go ahead and graph it on my TI-84. So let's grab our TI-84. And the way that you actually insert this into your TI-84 is going to matter greatly because there's like a bunch of freaking, division signs and everything. So first thing I'm going to do is I'm going to type in a negative. Negative's on the bottom. It's not a minus. You put a minus, it's going to be wrong. So look where the little red button is on the bottom. -2, close your parenthesis. Or actually I could do, yeah, we're going to have to do 2 parentheses. Sorry. So put another parenthesis. -2. Close that parenthesis, divided by parenthesis, x plus 2. Close out parenthesis. And close the parenthesis one more time. I know you're like, why are there 2 parentheses on top of a parenthesis? It's because you have your numerator. That -3 is going to mess you up. So you got to make sure the -3. And when I say minus, it's not negative, it's a minus button. So look at the little red button, 3. So make sure you have it inserted like this. Because the way that you insert things, it really does matter, you guys, or else it wouldn't work. Okay, so then with that said, let's go ahead and graph it. And this is your graph. So with your highlighter, go ahead and feel free to add the remaining parts of your graph. Okay, so it looks like this is my graph right here. I have this red piece right here, and it looks like the other red piece is right over here. Okay, so the red piece are your graph. And if you look at it, remember your vertical asymptote is a -3 or -2. -3 and then -4. So what that means is that we need to make sure that this information actually matches to the graph that you have right here. So let's take a look at that. So here's my graph. X equals -2. So -2 is right here. And guess what? That looks accurate because your graph does not touch the vertical asymptote. I also have y equals -3, and that's your horizontal asymptote. and your graph does not touch that. But your graph does go through -4, which is where it should be touching, okay? But that's how you graph it, and that's how you find it out. So now that I have this, I need to go back over here. Domain. Domain is left to right, okay? It is going to be from -infinity up to -2, union, and then it continues on from -2 to positive infinity. Okay, so that's your domain. Your range is up and down. How far up and how far down does it go? It looks like it goes all the way down to -infinity, but then it stops. Where does it stop? It stops right here at -3. It doesn't go by -3. So we put -3 right here, union, then from -3 all the way to positive infinity. Now let's go ahead and take a look at the end behavior, okay? So the end behavior basically says, as x approaches -infinity, okay? So as x approaches -infinity, which is actually, I'm gonna highlight it over here, this way, that's -infinity. Where is your y value going? It looks like my y value is going to a -3. That's what it looks like to me, okay? And then as x approaches positive infinity, so this way, where is your y going? Your y is still at -3. And that's how you answer all the questions about horizontal, vertical, y-intercept, domain, range, and end behavior, which is a lot, I agree. But you guys can do quite a bit with the TI-84 calculator. All right, let's go on to the next one. So for number 3, you have this equation right here. Let's just go ahead and graph it, okay? So you have a -2x minus 3, and this will be your last one, I promise, okay? And this one, it's gonna be really hard to identify. I know that my vertical asymptote is just the x plus 3, set equal to 0, x equals -3. I know that's easy to find. But for my horizontal asymptote, I don't know. There's like no numbers tagging along there. So I'm like, is it 0? What the hell is it? So if I'm not sure, let's just go ahead and graph this. So I'm gonna go ahead and graph this one. So with your calculators, we're gonna go back to y equals, and I'm gonna go ahead and clear that. Well, no, not graph it, clear it. And now let's go ahead and put that rest in. So you're gonna have parentheses, -2x minus 3, close your parentheses, divided by, and then we're gonna do x plus 3, close your parentheses. And you wanna write it like that mainly because you would really need to know how to go about graphing this and inserting the parentheses correctly, or else your graph is going to be looking weird. Come on, I want to go back to my calculator. Where's my shoes? And then you just go ahead and hit graph. Okay, so that graph looks like this. And so I'm going to just go ahead and take this and paste it over. You guys can go ahead and just graph it if you would like. Just copy it down. Okay, so I know my vertical asymptote is at -3. So I know here's -3. I'm gonna draw my line there, and my graph is not going to cross this line, okay? If I go back to what I just graphed, it kind of looks like it, right? Like there's x equals -3, and my graph does not cross that line. So my vertical asymptote is x equals -3, so I have that. Well, let's see what the y-intercept is. So your y-intercept is when x equals 0, and you ask yourself, what is y? So let's do that. So y equals, I have a -2 times a 0 minus 3 divided by 0 plus 3, which is a -3 over 3, which is a -1. So y equals -1. Okay, so when y equals -1, it's this point right here. Now, if I look at my graph, do you see how my graph actually hits that point? So then when I draw this, I just go down this way. There's my graph right there in purple. And then it doesn't look like I have well, it looks like my horizontal asymptote is at 1, 2, 3, 4. So y equals -4. So I'm going to go back over here. That's going to be my horizontal asymptote. And then I want to make sure I draw my graph, my other part of my graph down here. So right here in red. That's why I have you guys have highlighters. So that way you guys can see. Okay, so your horizontal asymptote is y equals, I mean, it's not easy to find it on the equation, but you can find it from the graph. Y equals -4. You got my y-intercept, your domain. Domain is how far does your graph go from left to right? So on the left, I see that my graph is, and let me make sure it's on the right. Oh, yeah, it is. My graph is going to -infinity, but it stops at this line right here, which is -3. So I'm going to say -infinity to -3 union, and then it starts from -infinity again, and it keeps going to the right. So positive infinity. So you just have to look at the graph to find that. The range is up and down. So your graph is going all the way down here, but then it doesn't go past the -4. Do you see that? So it's from -infinity to -4, union -4 to positive infinity. And the very last part is just your end behavior. And all you have to do with that one is as x approaches -infinity, and so that -infinity, I'm going to highlight it in black, -infinity right here. Where does your y go? Your y is going to -4. And as x goes to positive infinity, which is over here, where does your y go? It looks like this graph is getting closer to this blue line right here, and that's -4. And that's it. And if you guys can understand this, this is pretty awesome because this is like the beginning of pre-calculus, which is a senior level class. All right, so we're done with these 2 examples. Grab your 3 sticky notes, you guys. I have 2 little videos I'm going to show you guys. You're just going to write down your thoughts on the first one. So the first sticky note is number 1. Find the vertical and horizontal asymptote of a rational function. And so you're going to use your first sticky note to watch this video and jot down your thoughts, okay? Okay, so that should be on your first sticky note. Okay. And here he actually went over the 3 rules, which is great. So you get a little bit of exposure on that. But tomorrow I'll go over the 3 rules with you guys a little bit more specifically. Okay, so for your second one, it's going to be x minus 4 over x squared. So that's your second sticky note. All right, so then looking at this one right here, you guys, your vertical asymptote is 0 because we set this equal to 0 in the denominator. It is just 0. Now the rule is, do you see how the power on the bottom is bigger than the top? If the top is smaller than the bottom, it's just going to be 0. That's the second rule. And if you look at the graph, indeed, it is. Right there, y equals 0. Okay. All right, so third sticky note, go ahead and copy that one down. H of x equals x squared plus 4 minus x squared. Still offline. All right. And so the graph will look something like this. And you looked at this with the horizontal asymptote, it is right here at -1. Vertical asymptote, you have 2 of them right here at -1 or -2 and one at +2. Okay, so then with your 3 stickies, I want you guys to take that and stick it into your notes today, just over their notes that you went over. Just keep it in your guided notes for your white packet. And so now that we actually have gone over the 3 different rules, I just want to kind of reiterate it with you guys one more time. And I will go over this again tomorrow. All right, so I'm just gonna write 3 rules for horizontal asymptote, okay? And here are the 3. Okay, so for the first rule is if you have like an x squared over an x to the 4th, okay? Where do you see how the numerator is, or the power, I should say, the exponent of the numerator is bigger than the denominator, and in which case y is just 0. That's your horizontal asymptote, okay? That's the first one. Second one is going to be if you have x to the 4th over x squared, where the numerator power is smaller, or I'm sorry, the numerator power, I totally did this wrong, it's the other way. When the numerator power is bigger than the denominator, in which case your horizontal asymptote does not exist. There is not one, okay? It just doesn't exist. And the last one that you have is if you have like 4 over 6, x to the 3rd, x to the 3rd, where the numerator power is equal to the denominator power, and in which case your horizontal asymptote is just going to be the coefficient, which is the numbers in front. So y equals 4 over 6, which is the same thing as 2/3. And those are your 3 rules, which I'll talk a little bit more about tomorrow, you guys. All right, so then for your exit ticket, so it's gonna be week 5 Tuesday. Go ahead and use that QR code or the Google form right here to answer your questions. You guys have like 5 minutes. You have plenty of time.